Humanity's greatest space dream is a total thermodynamic illusion. For decades, billionaires, space agencies, and science fiction writers have sold us a breathtaking promise that we can transform Mars into a lush, blue world with oceans and breathable air. We are told with nuclear warheads, giant solar mirrors, or super greenhouse gas factories, we can awaken a dead world. But cold, unyielding astrophysics tells a brutally different story. Mars is not a fixer-upper awaiting human ingenuity. It is a permanent cosmic graveyard. The fundamental laws of thermodynamics, gravity, and atomic physics do not care about human ambition. Mars will never be Earth 2.0. Every year, hundreds of millions of dollars flow into research, propulsion concepts, and habitat designs aimed at colonizing the red planet. Tech leaders claim that within our lifetimes, thousands of terraformed Martians will walk beneath a blue sky. Yet when top planetary scientists and NASA astrophysicists run the physical equations, the dream instantly collapses. Terraforming requires altering a planet's atmospheric density, thermal equilibrium, and global energy balance. In this deep dive, you will discover the three insurmountable physical barriers that render Mars completely unterraformable. First, we will expose the missing magnetosphere and how solar wind turns any prospective atmosphere into cosmic dust. Second, we will reveal NASA's definitive volatile budget calculation, proving Mars lacks the raw materials to warm itself. And finally, we will analyze the gravitational escape trap, ensuring Mars can never hold on to air. Stay tuned, because the ultimate reality of space colonization will rewrite where humanity's future lies. To understand why Mars cannot hold an atmosphere, we must look deep inside its frozen, silent heart. 4 billion years ago, Mars was a dynamic world with liquid surface water and a thick sky. But its smaller planetary mass caused its molten iron core to cool and solidify far faster than Earth's. When internal liquid metal convection currents stopped moving, the planetary dynamo died. Without a dynamo, Mars permanently lost its global magnetosphere, the magnetosphere. Today, Earth's powerful magnetosphere acts as a force field, deflecting the solar wind, a relentless stream of high-energy charged particles blasted from the sun at over 1 million miles per hour. Without a magnetosphere, Mars is completely naked to this solar wind bombardment. In a process called sputtering, energetic solar ions slam directly into the upper Martian atmosphere at extreme speeds. They transfer momentum to individual gas molecules, knocking them out of the planet's gravitational grip and hurling them into interstellar space. Over billions of years, this solar erosion stripped Mars of its original thick atmosphere. Proponents of terraforming suggest we could simply release vast quantities of gas to thicken the atmosphere, but doing so without a magnetosphere is like trying to fill a bucket that has its entire bottom blasted out. Even if we could somehow generate an atmosphere overnight, the solar wind would erode it continuously. Proposals to deploy an artificial magnetic shield at the Sun-Mars L1 Lagrange point require constructing a magnetic dipole with a power output equivalent to thousands of nuclear reactors, an engineering concept requiring materials and energy scales that exist only in theoretical physics. Without an internal dynamo, any attempt to build an atmosphere on Mars is an exercise in endless, futile atmospheric replenishment against a relentless solar cosmic wind that strips away volatile elements faster than human technology could ever synthesize them. Yet, even if we magically turned off the solar wind tomorrow, an even more fundamental physical barrier exists right on the Martian surface, one that makes creating a thick, warm atmosphere mathematically impossible, regardless of how much time or technology we possess. The most popular terraforming strategy involves triggering a runaway greenhouse effect. The concept sounds simple. Heat up the Martian polar caps using giant orbital mirrors or thermonuclear detonations, releasing trapped carbon dioxide gas into the air.
As CO2 enters the atmosphere, it traps infrared radiation, raising global surface temperatures, which melts more polar ice and releases even more CO2 in a self-sustaining warming loop. However, in 2018, a landmark study published by NASA researchers in Nature Astronomy delivered a fatal blow to this popular concept. They conducted a comprehensive inventory of all volatile carbon dioxide locked inside Martian polar caps, shallow soil, and carbonaceous rocks, using decades of high-resolution satellite and surface rover data. The result was indisputable. Mars simply does not possess enough carbon dioxide to create a viable atmosphere. To warm Mars enough to support liquid water, atmospheric pressure must rise from its current level of 0.6% of Earth's sea level pressure to roughly 100%. However, if we completely evaporated every single molecule of CO2 trapped in Martian polar caps, atmospheric pressure would only rise to about 1.2% of Earth's sea level, nowhere near enough to prevent surface water from instantly boiling away in a near vacuum. Even if we baked the top layers of the entire planet's soil to extract absorbed gases, total pressure would reach, at best, 5% of Earth's atmospheric pressure. Furthermore, carbon dioxide alone is a weak greenhouse gas at low temperatures. Because Mars sits 1.5 astronomical units from the Sun, it receives less than half the solar energy Earth receives. To compensate for this massive solar energy deficit, Mars would need an atmosphere thicker than Earth's, consisting of exotic, synthetic greenhouse gases like chlorofluorocarbons. Synthesizing these artificial gases on Mars would require industrial complexes consuming millions of gigawatts of continuous electrical power, using chemical raw materials that simply do not exist on the planet. Mars is not a frozen reservoir waiting to be unlocked. It is a chemically depleted planetary desert. And as daunting as the chemical volatile deficit is, the fundamental laws of gravity impose an even harsher physical sentence on Mars's atmospheric ambitions.
Even if we could somehow import trillions of tons of volatile gases from the outer solar system by redirecting thousands of icy comets from the Kuiper Belt, Mars would still fail a fundamental law of physics: Jeans escape. Jeans escape is the physical process by which gas molecules in a planet's upper atmosphere gain sufficient thermal energy from solar heating to exceed the planet's gravitational escape velocity. Mars's surface gravity is only 38% of Earth's, giving it an escape velocity of just 5.0 kilometers per second, compared to Earth's 11.2 kilometers per second. Because Mars's gravitational pull is so weak, lighter gas molecules like hydrogen, helium, and water vapor move at thermal velocities that routinely exceed Mars's low escape threshold. When ultraviolet light from the sun hits water vapor in the upper Martian atmosphere, a process called photodissociation splits H2O molecules into hydrogen and oxygen. On Earth, high gravity keeps oxygen locked in the atmosphere and heavy enough to resist thermal escape. On Mars, because the gravitational well is extremely shallow, light hydrogen escapes almost instantly into space, leaving behind oxygen that rapidly oxidizes surface minerals, turning the soil red. Any water imported or released on Mars would be systematically dismantled by solar UV radiation and bled into space atom by atom. Furthermore, Mars lacks a nitrogen reservoir. Earth's atmosphere is 78% nitrogen, an inert buffer gas providing the bulk of our atmospheric pressure without causing runaway toxicity. Mars has virtually no active nitrogen cycle and negligible nitrogen deposits. Without nitrogen, any high-pressure atmosphere created on Mars would consist of pure CO2 or oxygen, creating a lethal, highly corrosive, and hyper-flammable surface environment. Mars's low planetary mass is a permanent gravitational constraint. You cannot terraform a planet's mass. Mars is simply too light to hold a living, pressurized atmosphere over geological timescales. The ultimate revelation is stark. Mars terraforming is not an engineering problem awaiting futuristic technology. It is a direct violation of fundamental astrophysics. Mars lacks the planetary core to generate a magnetic shield, lacks the volatile inventory to build an atmosphere, lacks the solar energy flux to warm its surface, and lacks the gravity to hold on to light elements. Terraforming Mars is physically impossible. Humanity will never walk beneath an open Martian sky. The physics of our solar system have permanently closed that door. Understanding why Mars cannot be terraformed does not mean space exploration is dead. It means our focus must shift from naive planetary makeover fantasies to real, sustainable engineering solutions. If humanity is to become an interplanetary species, we must build artificial closed-loop orbital habitats, subsurface pressurized cities, or look toward worlds with true volatile abundance. Earth remains our only natural oasis in the cosmic void. Subscribe now and hit the notification bell for our next Cosmic Deep Dive.